In the diagram below, a 2 kilograms block is connected to a 1 kilograms block by means of a light inextensible string. The blocks are pulled up an inclined plane, which forms an angle of 28 degrees to the horizontal. The sides of the blocks which touch the inclined plane have the same area. The kinetic frictional force between the 1 kilogram block and the inclined plane is 4 newtons, while the kinetic frictional force between the 2 kilograms block and the inclined plane is 8 newtons. First question is, draw a labeled free body diagram showing all the forces acting on the 1 kilogram block. And so, for 4.1.1, we simply need to draw the free body diagram for the 1 kilogram block. And so if we examine this block, and obviously in a free body diagram, we represent the block or the object with a dot. And now our block here is lying on an inclined surface. So maybe we can show that with a dotted line and indicate that this is 28 degrees. And so the surface, as always, will exert a normal force on the 1 kilograms block. And so the normal force is always perpendicular to the surface, which is why we are drawing it slanted like this. This is so that it forms an angle of 90 degrees with the surface. As with every other object that is near the surface of the earth, this block will experience a gravitational force or force of gravity Fg, which is always directly downwards towards the center of the earth. And so that's our gravitational force, which we can also call the weight of the object. And then, as shown in this diagram, there is an applied force which is parallel to the plane. And this, we can just call it our applied force. And we can see that we have also been given its magnitude, but we are not concerned with that for now. And so we need to show these arrows on top of our symbols here for each force to show that these are vectors. And then, of course, as stated, this 1 kilogram block is experiencing a kinetic frictional force. And so the frictional force will be opposite the applied force. It's always opposing the direction of motion. And so this is our kinetic frictional force for this case. And then in addition, it's very important not to forget this one. There is also a tension force between the two blocks. So the 1 kilogram block will experience a tension in the string, which is due to the 2 kilograms block. So the direction of that tension as experienced by the 1 kilograms block will be downwards. So it will be downwards. We don't really know the relative magnitudes of these forces for now, so it does not really matter whether which one is longer than the other. Okay, and so these are all the forces that are acting in the 1 kilograms block, and we have shown them in a free body diagram. And so here is an additional hint. This is for 5 marks, so it's a hint that there are 5 forces that you need to show that are acting on this 1 kilograms block. And as you can see, we've got 1, 2, 3, 4, 5 on our diagram. So you can always check the mark allocation to give you an idea whether or not you have shown all the forces acting on that particular object. Okay, so The next question here for point 1.2 is simply asking us to state Newton's second law of motion in words. So I'm sure that we all can manage to do this. If not, you can just always refer to your notes and try to read it with understanding up until you are able to state it without reading it. But for now, let's move on to the more interesting question here, 4.1.3, which says calculate the magnitude of the tension in the string connecting the blocks. So we want the magnitude of this tension that is in the string. Okay, and so to answer this one, we need to make sure that we have an idea as well of all the forces that are acting on the 2 kilograms block. So although we were not asked to draw a labeled free body diagram for this block, it would still be very helpful for us to draw it so that it can help us in answering the question. And so this block here is also going to experience a normal force, and the normal force is exerted by a surface and it is always perpendicular to that surface. So it will be on this direction even for the 2 kilograms block. And the gravitational force is always directly downwards towards the center of the earth, regardless of the plane, whether it's an inclined plane or a horizontal plane, but the FG is always directly downwards. And then this block here, as it was stated on this paragraph, it also experiences a frictional force, which is down. Okay, so this experiences a kinetic friction. And then in addition, there is the tension force. And now the 2 kilograms block will experience a tension force upwards because it will be due to this 1 kilogram block. And so to answer for point 1.3, we can apply Newton's second law of motion, of course. And mathematically, this law says that F net is equal to MA. But now in this problem here, we have a system of blocks. So we've got a system which is made up of 2 blocks. And the strategy that we can employ here is that we can apply the second law in each object individually and then solve the equations simultaneously. So for an example, we can start with the 1 kilograms block. So maybe let's write that for the 1 kilograms block, and we are taking upwards as our positive direction. So upwards the plane, or let's just say to the right, up the plane will be our positive direction. And so F net is equal to MA, as we had already shown. Now for the 1 kilograms block, we can just use the free body diagram we had already drawn in 4.1.1. And we need to take into account all the forces that are acting parallel to the plane, because when this block, or in fact both of these blocks, are moving, they will be moving parallel to the plane, that is up or down. And so we must only consider those forces that are parallel. And so for this 1 kilograms block, we can say that there is the applied force there. And since we have taken to the right to be the positive direction, that applied force will be positive. So we'll have here a positive FA. And then we see that we've got 2 forces that are acting in the opposite direction. It's the kinetic frictional force as well as the tension force. So they are both negative. And now we need to be mindful of the fact that since this is an inclined plane, the gravitational force here is going to have a perpendicular component and a parallel component. And we can show them like this. So there is a perpendicular component, and we call it a perpendicular component simply because it is perpendicular to the inclined plane in this case. And so this is FG perpendicular. And we can show the parallel component like this, and it's always down the plane. So this would be FG parallel, okay? And if we want, we can then move this FG parallel down so that it closes this gap here between these two forces. And so that is our FG parallel. And now the nice thing about showing it here is that you now form this right angled triangle because the angle between the FG perpendicular and FG parallel is 90 degrees. And also we know that this angle here that is between FG and FG perpendicular is equal to this angle of 28 degrees. Okay? And in fact, you can also show this free body diagram this way. So instead of showing the gravitational force here, you can just simply show its components in the free body diagram. So you can just show the FG perpendicular and FG parallel in the free body diagram instead of showing just the FG. Okay? And so both of these would be accepted when you are presenting your free body diagram. Anyway, let's go back to the question. And so, as you can see here on our diagram, FG parallel is part of these forces that are parallel to the inclined plane. So it will also contribute to this net force. And as we have shown, it is acting downwards the plane. So it's also going to be negative. So here we also have negative FG parallel. And all of this is equal to MA. And now, from this step, we can start substituting in all the values that we know. For an example, the applied force here, we were told that it's 30 newtons. And so we'll write 30 there. The kinetic friction for the 1 kilograms block, we were told that it is 4 newtons. So we will minus 4 here. And then the tension, it's what we are trying to solve for here. So it's our unknown. And then FG parallel, we do not know its value, but we can actually calculate it. And we can show this calculation on the side if we want to. In our current diagram here with the components, we can see that FG parallel is opposite this angle of 28 degrees. So it is the opposite side, whereas FG is the hypotenuse side, since it is opposite the right angle. And so the ratio that can relate the opposite side to the hypotenuse side is sine, because sine of theta is the opposite over hypotenuse. And so for us, the opposite is FG parallel, while the hypotenuse is FG. So we have sine theta on this side, which means that if we multiply by FG on both sides here, we will then get an expression for FG parallel, which will be FG multiplied by sine of theta. So in place of FG parallel, we can write FG sine of theta, and our theta is 28 degrees. And we also know that FG is equal to mg. So for our object here, the mass is 1 kilograms. So we'll have 1 for the mass multiplied by 9,8 for g. So that is for Fg. And we need to multiply this by sine of theta. And our theta is 28 degrees. So we'll write 28 degrees here. Our mass is still 1 kilogram. The acceleration, we don't know the acceleration. We were not given any information regarding that. So we'll just write A here. Okay? And now we can just simplify our expression here by adding all the like terms. So let's whip out our calculator for that. And so let's start by calculating 1 multiplied by 9,8 sine of 28 degrees. And so this is equal to 4,6. And therefore here we'll have 30 minus 4, which is equal to 26, minus the tension minus 4,6. So all of this must be equal to A, because 1A is just simply equal to A. And now lastly, let's add up these numbers here. So we have 26 minus 4,6, which is already our answer in the calculator. So we get 21,4 if we round it. So we have 21,4 minus t is equal to A. Okay, and we will just leave this equation like this and just call it our equation 1. Okay, and now we need to basically do the same thing, but now for the 2 kilograms block. We will also apply the second law. So F net is equal to MA. Okay, and now here, the forces that are acting parallel to the inclined plane is the tension, which is acting upwards the plane, and so it will be positive. We then have the kinetic friction, which is acting downwards the plane, so it will be negative. And then this is an inclined plane, so let us not forget that we have a parallel component for the gravitational force. So even here, we have a perpendicular component, FG perpendicular, as well as FG parallel. And FG parallel always acts downwards the plane. So we must have minus FG parallel here. And so all of these forces must be equal to the mass multiplied by the acceleration of the 2 kilograms block. And now we can plug in all the values that we have. And we still do not know the value of the tension. We do know that the kinetic frictional force between the 2 kilograms block and the inclined plane is 8 newtons. And then for FG parallel here, so again, we know that this angle here is equal to the 28 degrees, and it is opposite FG parallel, okay? And so opposite over hypotenuse is sine of theta, which means that FG parallel will be equal to FG multiplied by sine of 28 degrees, okay? And so in place of FG parallel, since we know that FG is also equal to mg, so here we write mg and then we multiply it by sine of 28 degrees. So the mass of this block is 2 kilograms, so we'll write 2 here. G is 9,8 on earth, right? And so we multiply that by sine of 28 degrees equals to the mass of the block, which is 2, and the acceleration is still an unknown as well, so we just write a there. Okay, and now here we can add up all the like terms, and for that we need a calculator. So let me whip out our calculator, and then maybe let's move it to the right. And so we will carry down t, and for now let's carry down 8 as well, and then evaluate the value of FG parallel. So we have 2 multiplied by 9,8 multiplied by sine of 28 degrees, and so this is equal to 9,2. And so all of this should be equal to 2a. And now we can combine these two like terms here, which is 8 and 9,2. So we need to find the value of minus 8 minus 9,2. And so that's equal to minus 17,2. And so all of this should be equal to 2a. And then we can just leave this as it is and just call this equation number 2. Okay? And now we have got two equations, and in both equations we have two unknowns, the acceleration and the tension, acceleration and the tension. And since these two blocks here, the 2 kilograms block and the 1 kilograms block, are connected by a string, so this tension, the magnitude of this tension that is experienced by each string is the same, and also the acceleration experienced by each of these two blocks is also going to be the same, because they are a system, they are connected to each other. So when they are moving, they will move as a whole. And so because of that, we can solve these two equations simultaneously because they have got the same unknowns. And in order to do that, we can simply substitute equation 1 into equation 2. And our equation 2 is t minus 17,2 is equal to 2a. But now, in place of a, we are going to write the expression that we have obtained from equation 1. So in equation 1, we found that a is equal to 21,4 minus t, right? And now we just need to simplify this expression and solve for t. So this side we are still gonna have t minus 17,2, and now we need to multiply by these two into the bracket. So 2 multiplied by 21,4 should be 42,8. Yes. And then 2 multiplied by negative t should be minus 2t. And after this, what we can do is we can transpose this term here, the negative 2t, into the left-hand side. So we'll have t plus 2t. And then we also transpose the negative 17,2 into the right-hand side, so that we have 42,8 plus 17,2. Okay, and then t plus 2t is going to be equal to 3t. And then we simply need to add up these two numbers. And for that, let's just use our calculator. So we have 42,8 plus 17,2. And this is equal to 60. And so in order to find the value of t, we need to divide both sides by 3. And so the value of t will be 60 divided by 3, which is equal to 20. And so the magnitude of the tension in the string connecting the two blocks will be 20 newtons. So do not forget the units. So tension is a force, so its unit is newtons. So this would be our final answer for this question. And now here is the next part of this question. Now the two blocks here have been interchanged so that the same 30 newtons force is now acting on the 2 kilograms block, and still they are along the same inclined plane as shown on this diagram. And the first question they are asking here is, how will the acceleration of the system change? Is it going to increase, decrease, or remain the same? And another question here is, how will the tension in the string connecting the two blocks change? Is it gonna increase, decrease, or remain the same? And so, what do you think about this question? And just comment what you think in the comment section, and I will reply to your comment. I'll tell you if you are correct or not. And you can even make it more interesting by giving a reason for your answer. So I hope to see you in the comment section. Otherwise, if there is a need or high demand, I can just make a quick video explaining it. But tell me what you think first.